Alrighty, so now the last section of our describing univariate data, I split my unit 1 into 2 units, so the second half of this unit will be about the normal distribution. But for now, we're going to wrap up just describing data. And there's not really new concepts in this lesson. Really, it's just combining what we've already learned, and that's going to be used in order to compare distributions. So we've been looking at one sample statistics. But most times comparative statistics are used as opposed to that single sample because you're wanting to compare what works and what doesn't work. Now, this is done so that we can see how different groups compare to the same treatment or the same task. For example, we could compare different gender identities, classifications, or any type of unique characteristic that would separate our population of interest into more specific subgroups. So since we're going to be comparing distributions, we must use comparative language. And these are going to be our ER words. So for example, greater and larger, or things like smaller and lesser. Or maybe sometimes there's not a difference, so maybe we can say similar to. And a specific one for shapes, so I'll put this one in a different color. Shapes, you can't really compare the shape because it's categorical data there. So I can't be this is the average shape, but I can say this distribution appears approximately symmetric, whereas this distribution appears skewed to the right. But so this is only going to be for shapes. For all of the other features, so for center, spread, and anything unusual, you are going to explicitly need to name the location of it and give it context. Shapes, you can get away with this one's skewed right, whereas this one's approximately symmetric. But for medians, you can't say this median's 32, whereas this median's 45. Okay, that doesn't compare them to me. Yeah, I guess 45's larger, but nobody told me that. I just know one's 32, one's 45. What if I have no number sense? How am I going to know which one's larger, which one's smaller? So you need to make sure you apply that comparative language there as you are working through these types of problems. Now, most times it's common to have a section of this in the FRQs, but it also shows up in the multiple choice. So we're going to do practice of both of those today. So we're going to take a look at this FRQ from 2005, and we're just going to practice what you would need to say. So write a few sentences comparing the distribution of the daily caloric intake of 9th grade students in the rural high school with the distribution of the daily caloric intake of 9th grade students in an urban high school. The data displays the number of calories of food consumed per kilogram of body weight for each student on that day. Now, because I'm a bully, I am going to make you find the summary statistics for both sides and then explicitly name them. But on the AP exam, you only need to mention what statistic it is, give it context, and compare those statistics. So for example here, if I were to look at the median, so even just eyeballing here, I'm going to look at the middle of this distribution, and I'm pretty sure the middle of the distribution's right about there. Whereas here, I'm looking at the middle of the distribution, and I'm pretty sure it's going to be right about here. Well, which median is larger or smaller? Well, here it looks like the median's in the lower 30s, whereas for rural students, it looks like the median's in the upper 30s. So I would comment on that. Now, things with shapes. This is what we call a back-to-back stem plot. So let's write that in. So a back-to-back stem plot. Now, on a back-to-back stem plot, you always need to tilt it on its side. So for example, if I'm going to look at it here, well, the rural one looks approximately symmetric. But if I look at the urban, I'm tempted to say it's skewed left, because if I were to draw on this, I would say, oh yeah, well, tilting my head, the tail's going to the left. But even aside from just looking at it, let's take a look at how the numbers are comparing. Notice the numbers are increasing in value. So this tail, although it looks skewed left, the tail is following those larger output values. And when your average would follow those larger values, that's actually skewed right. So just make sure you take that into account when you're looking at back-to-back stem plots, because that's how they're going to trick you. So you need to tilt it on its side and draw the shape on there, and then you can't trust nobody, so you got to check, are the numbers going higher, are they getting larger, or are they getting smaller? And that'll tell you the direction of the skew. So let's actually now compare these distributions. So at a minimum, you just need to discuss the center, the shape, and the spread. Anything unusual may or may not happen, but if you don't notice anything unusual, then you don't have to comment on it when you're comparing, unless there's explicitly an outlier or an explicit gap. But other than that, we don't really have to mention peaks unless the shape is unimodal or bimodal, then you'll want to mention that. So you can see all these what if and wiggle words. So let's put our context here. So the median caloric intake for rural students is greater than the median caloric intake for urban students. And so for my students, I'll have you actually find those summary statistics so you can believe me, but not today. So you can see there, I've got context. And notice I'm not just saying the median is greater for rural than for urban. Again, it's two separate distributions, so you need to make sure you provide both context for both statistics. And here, notice that I use the median caloric intake, rural, urban. And then where's my comparison word? Greater. Perfect. So now let's talk about the spread. So the range of caloric intake. So if I look there at the urban students, 42 minus 26, that's about 16. Whereas if I look there at the urban students, 51 minus 32 is about 19. So even though they both span across 4 intervals, I would actually need to look. Oh, actually, no. Look, the rural students span across 5 intervals. And we just mathematically confirmed that there would be a larger range there. So the range of caloric intake for, let's switch it up, for urban students is less than the range of caloric intake for rural students. And so notice there's no particular error. The comparison just has to be relative to what you're comparing. So notice in the first sentence I said rural was greater than urban. Now here I'm saying urban is lesser than rural. Again, you just have to be consistent with your context there. Now let's talk about the shape. So the shape of the distribution for urban students appears unimodal and slightly skewed to the right. Whereas, because now they just have two completely different shape categories, so it wouldn't make sense for me that to say like my skewed right is greater than skewed left. Like, no. So, whereas the shape of the distribution of the caloric intake for rural students appears approximately symmetric and uniform. And look, I forgot my context here. The shape of the distribution of caloric intake. And like I said, there were no notable gaps or outliers, so I'm not going to comment on those. So at a minimum, center, shape, and spread. We need to make sure there's context, which there's plenty of that, and then that comparative language. So we talked about the medians, we talked about the range, and we talked about the shapes of the two distributions here. So this is actually enough to warrant full credit for the AP exam. Because I'm a bully, I'm going to make my students comment also on unusual features. I'm going to make them find the summary statistics. But for those of you who have stumbled onto these lessons, you're good to go. You just need a basic comparative language there. My students will get there in April or May. So here is a few multiple choice practice questions for you, as well as another FRQ. So I would say pause the video. Nope. I am going to say pause the video and try these out for yourselves, and then we'll review them whole group. So go ahead and pause the video, use your notes, find those statistics, and make some comparisons. Alrighty, so hopefully not too difficult, and I'm not going to go into detail. We're going to discuss these in class, but here are the correct answers to check your work. So we can see that the IQR for the healthy chips is larger than the IQR for the regular chips. Here in this, so that was a box plot and stem plots. Now let's go to dot plots. Here we can see, you could calculate these by hand, but also just by inspection. We can see that the range for the corn is greater than the range for the soybeans. So again, just looking at the distributions and comparing them. And then lastly, a histogram. And we would actually need to connect this to lesson 1.7, where we looked at the different shapes of the histograms and the box plots and the connection between the two. But here is one important thing I need you to write down, and we'll discuss this in class. But a bimodal distribution will always have a greater standard deviation than a unimodal distribution. And thinking about this, it's because standard deviation measures that average distance between observations and the mean. So here in unimodal, most of the observations are at the mean, so there's going to be less change here, whereas for bimodal, the mean ends up in the middle, but most of the observations are further away from that mean. So typically there's going to be a greater standard deviation for bimodal than for unimodal. And then lastly, one of my favorite compare the data questions. This one comes to us from 2015, FRQ exam from the FRQ number 1 on there. You would just make comparisons. So at the very least, the centers are approximately equal. For spread, I see that Corporation A has a larger IQR than Corporation B. Corporation A appears slightly skewed right, whereas Corporation B appears approximately symmetric or approximately skewed left. Corporation A has 2 upper outliers, whereas Corporation B has no outliers. So there you go. We're actually I gave you the answer there, but we're gonna do this in class. We'll take 12 minutes to try this out, and then we're gonna use a rubric, the AP rubric, to actually grade them. So that's actually gonna wrap up our first half of Unit 1. So we talked categorical data, quantitative data, ways to describe both of those types of data, ways to display both of those types of data, and then lastly, ways to compare those types of data. So we're just going to keep practicing for the rest of the time being, but in the next few lessons, this is going to be my Unit 1B, and we'll get into using the infamous normal distribution. So thank you all for tuning in.